Hello dear students. So we are going to start new rearrangement, that is Wolff rearrangement. So let us see what is Wolff rearrangement. So in Wolff rearrangement we have alpha diazoketone. Okay. We have alpha diazoketone. Alpha carbon have diazo group. Okay, this alpha diazoketone. Here is CH3. Okay. So we treat our alpha diazoketone with silver oxide, heat or light, which gives us carbene, and then that carbene undergo rearrangement to form a ketene. So let us solve this example so that you can understand what is Wolff rearrangement. Okay, here you can see I have taken alpha diazoketone. Okay, I have just written its resonance form, resonating structure, nothing else. Okay, and this structure is treated with any one of these. All three are not we are using any one of these, but what else you can use for silver oxide, or what else you can use instead of heat or light, I have shown all those three. Okay, so what is role of these three? Just to form carbene. Okay, then the carbene, thus form carbene, is undergo rearrangement to form a ketene. So what is ketene? This structure is known as ketene, with carbon have double bond, carbon oxygen have double bond. So now this ketene get attacked by nucleophile. What nucleophile we have? We have water. Okay, so ketene get attacked by water. Oxygen, lone person oxygen attacked on carbon, then that carbon shifted its electron towards oxygen, O minus, at water get attached to our carbon. Then deprotonation takes place. For deprotonation, water molecule takes proton from this O oxygen, and new positive charge on oxygen get neutralized, and it is removed in the form of H3O plus. Hydrogen is removed in the form of H3O plus, which is get used in next step here for protonation of this carbon. Okay, and this carbon get protonated because of H3O plus. Oxygen's transfer its electron towards the carbon to form here new pi bond, and this pi bond takes proton from here, and new hydrogen gets attached to this carbon, and we get our acid as our final structure. Here you can see this carbon takes proton, get protonated, so we get acid as our final product. So this reaction is somewhat interesting because we always not get acid as our final product. It is depend on the nucleophile. Like here we have used water, and therefore we get our product as acid. But instead of water, if there is another nucleophile, so we get different kind of product. Okay, so here you can see, here we have used water like in previous example, and we get acid. But instead of water, if we have used alcohol like methanol, here I have shown, it will give us ester. And instead of alcohol, when we use ammonia, it gives us amide. Okay, so remember this, we will not always get acid as a final product. It depends upon nucleophile. Okay, whether there is water, methanol or ammonia, you have to check that, and depending upon you have to do the mechanism and form product. Okay, so let us see our next example. Okay, so in this mechanism or example, you can see here I have taken silver oxide and nucleophile is methanol. Okay, this is also alpha diazoketone. Here is vinyl group, benzene ring. Okay, so let us see the mechanism. What is the first step? Just write its resonating form pi bond over here. Okay, and oxygen get negative charge. Okay, what is the next step? Just a removal of nitrogen. N2 is liberated, and because of that carbene is formed, and rearrangement will take place on carbene. Group attached to the carbonyl center migrated towards carbene and pi bond will form over here, and so we get our species ketene. Carbon carbon have pi bond, carbon oxygen have pi bond. Now next step is what? Attack of nucleophile. Which nucleophile we have? We have alcohol, methanol. Okay, so we will attack our ketene with methanol. Lone pairs on oxygen of methanol attacked on carbon, and then what will lone pairs on oxygen of methanol attacked on a carbon, and then electrons form involved in pi bond formation transfer towards O minus, and what will happen next? Deprotonation. CH3OH will take proton from here, and oxygen positive charge on oxygen get neutralized. I have by mistakenly written here H3O plus. Here H3O plus will not remove because we use alcohol for deprotonation. So what we will remove? This H2O plus and CH3, this, okay, which we have used in this step for protonation of our carbon. Like in last example we have used H3O plus. Okay, so these electrons form pi bond over here, this pi bond take proton from here, and we get our final product ester. Okay, so when we use alcohol we get our final product as a ester. Okay, so let us see next example. Here you can see something different. So this is not another rearrangement, this is also Wolff rearrangement. But how? So sometimes examiner don't give you directly diazoketone, you have to prepare diazoketone, and after that you have to done rearrangement. So how you will form diazoketone if you have such kind of reaction or such kind of example? They have given you COCl2 triethylamine or SOCl2 and triethylamine. What is role of these two reagent? Just chlorination. Okay, they have convert carboxyl group into chlorine. Okay, OH will convert it into chlorine. And what is, but we don't get our diazoketone still. So for that another reagent will be given there, that is diazomethane. Okay, so this diazomethane will attack here in electrophilic center, and our chlorine is removed. As we know that halogens are good leaving group, so Cl minus will remove, and this diazomethane get attached to our carbon. Okay, carbonyl center, and after that again diazomethane will take proton from here and it forms carbanion over here. Okay, and after that our reagents which we have seen in our previous examples were written in that example. Let me show you here. Here you can see they have given you COCl2 triethylamine. What is role of this reagent? Just you have to replace OH with chlorine. Here chlorination will take place. After that what they have given? CH2NH2, that is diazomethane. What is role of it? It will attack on our electrophilic center, and chlorine will remove. Okay, and it will give us diazoketone. After that diazoketone formation, here what is given? Third reagent is HNu and CH3 CH2 CH2OH, which is nothing but a alcohol. Here they have given us HNu, means light. So what as we have seen in our previous example, what is the role of HNu? Or heat or silver oxide? Yes, its role is to form carbene, and after carbene formation rearrangement will take place, and it gives us ketene, and that ketene will get attacked with this nucleophile. Okay, this is propanol. We will attack our ketene with propanol, and this will add over here propanol. Okay, so try to solve this example by your own. I will upload another videos of these examples. Okay, this is also the same kind of example. I have given here different reagents, here HNu, here heat, and here AgNO3. we have silver nitrate here. So the role is same. We will use this for formation of our carbene. Okay, and here they have given water as a nucleophile, here alcohol, here substituted amine is given, so we will get amide as a final product. Here we will get ester, here acid. Okay, try to solve it by your own, and I will upload the video, or we will discuss in our class. Okay, these are some theory part for your better understanding. So I hope you understand well this rearrangement. Try to solve examples, and best of luck. Thank you.